start by logging into Kali and also starting up your Vulnix machine. Can you guys see the Vulnix machine in the square?
Yep.
All right, cool. So the first thing we're going to do is actually figure out where the Vulnix machine actually is. We're going to need to do some host discovery. And it's a pretty simple process. Good way to go about it is to do IP address, find out what subnet you're on. We are on 192.168.80. So we can do a simple nmap-sn. The SN just says don't do port scans, so it makes it a lot quicker because we just want to find the host. We don't want to find what services are running on the ports. So we do that for 192.168.80, not 133. We'll do 1 because that's a gateway, and then 24 for our subnet mask. And after we do this, it'll give us a whole bunch of hosts which are on our subnet. 1 and 2 is not that interesting because they're probably just gateway stuff. 254 is near the end of the IP range, so it's probably reserved for some similar sort of function. We are 132, so this 133, which is next to our name, is pretty interesting. So we'll just give it a quick confirmation on 2.168.80.133, and then we can see there's a bunch of interesting services running. So now that we have our thing, what we're going to do next is a proper port scan. To quote IPsec from YouTube, nmap-sc for default scripts, -sv, enumerate all versions, output all formats, and call it desktop, Blair, and then type in the host name. 80.133, we're not going to do that because it takes too long, so I have some pre-prepared results for us. We can see a bunch of services. Port 22 open for SSH. I don't usually look at SSH, there's not that much interesting about it, and you'll rarely find exploits for OpenSSH on these sorts of machines. But what you can do to check it out is just chuck in search exploit. SSH5. You got a few things. None of these really work, so I don't know, don't bother. I haven't seen any of these actually work ever, but apparently they're there. So it's just something to check out, maybe try, but there's usually nothing wrong with SSH which you can exploit. The second one is port 25, which is SMTP, Simple Mail Transfer Protocol. And this is pretty much just an email thing. And you're like, how do I use an email to hack this Vulnix machine? Well, if you look at the SMTP commands, you have Vulnix, pipelining, size whatever that is, VRFY, and all this random crap that we don't care about. The one we care about is VRFY, which stands for verify. So if you connect to the machine, 80.133, on port 25, you can see that's running Vulnix SMTP. And if we try verify root, we can check if root exists on the machine. And you'd normally use this to check if some email address exists on the machine so you can actually send messages to people. If you type in one that doesn't work, like slamming the keyboard, I exited out of VMware, never mind. Cool, my keyboard isn't registering the inputs anymore. Alright, I'm unplugging that, I'm plugging it back in. If I broke my keyboard, I'm gonna be sad. Oh, there we go. No, still doesn't work. Cool, awesome. Thanks. Thanks. Let's see if this actually... Alright, it's something with the VMware. I should not have smashed my keyboard. That's very bad. Alright, let's restart Kali. It's not working.
Wait, does the keyboard work at all?
Yep, it does work. It's just this terminal. I don't know why the terminal froze when I smashed my keyboard, but that's how it works. Let's get back into it. Alright, VRFY. I will not smash my keyboard, I'll type in some random crap. And so if you insert an address that doesn't exist on the system, it will say recipient address rejected. So we can use this to effectively probe for usernames. And as you could guess, the the thing is brute forceable. You can just give it a list of things and list of Unix usernames and check if they exist on the system. And this can be really helpful for doing things like brute forcing or password spraying and things like that. So we'll exit out of this and then we'll use smtp user enum, which is a tool that automates this process. You can specify the method, which is verify, and then you specify a user list, which will use user share Metasploit framework data wordless Unix users. And then you specify the target, which is the IP of the machine. We'll pipe it into users2.txt and then look at the format. The reason we use users2.txt is because I have a users file which has some processed input, just to save time. Where is it? Screw GUI, don't use GUI. Let's open it. So the output looks something like this. It will put some info you don't really care about, and then it will show you the results of the scan. It will tell you which users from that user list actually exists. And then what you can do is that take that input, trim all of the fat off, and then you have a list of users that exist on the machine. So a lot of these are just default users. We don't really care about them, they're not too useful. One thing that if you're perceptive, you'll pick up is that user exists here, and it is a Unix username, but it's pretty uncommon. So we'll have a look around, see if there's anything we can do with that. The next service is Finger. That's the service. But you can use Finger to basically get a bit more information about what users exist on the system. And it's a really simple command to use. If you want to do it, you go finger root at 192.168.80.133. And then you can check if the root user exists on the system. If it has a directory and stuff assigned to it, that means it does. And they also have a shell called binbash, which is your bash shell. One other helpful thing Finger does for us is it tells us what shells are assigned to them. So a lot of these services a lot of these users assigned to the services will have a shell assigned called /bin/false. And that pretty much means you can't access the machine with the shell using that user, which is a good security measure because it just means that those services shouldn't be able to be hijacked or anything like that to get you a shell. So we will feed this user list into a script, Finger user enumeration. I tried this, doesn't work, utterly useless. And it looks like this. If it works for you, then great. Doesn't work for me, I don't know why, but it's a very simple script, so you can literally just do it yourself in a single line bash command loop. So if you don't know anything about bash scripting, it's pretty self-explanatory. It's a very syntactically simple language. So if you do like, well, read u, this just reads line by line from a text file, and do tell it what to do. And this is just the bash command, finger u, the variable, the value of the variable at this address. Then you pipe the input from users.txt. cd, desktop, never mind. Root. Don't even need to do that. Open terminal. Still not desktop. There we go. And it will just pretty much brute force Finger at the specified IP address for each one of the users in our user list. It's pretty quick, so we'll just run through all of it. And here you can see some instances of bin/false, as I was talking about. So then we see, obviously, a root, all caps, no such user, it doesn't really matter. But our Unix usernamed user over here has a home directory, home/user, and a shell bin/bash. So that's pretty interesting to us. We will keep that in mind and see what we can do with it later. POP3 is another email service. You can take a look at it and see if you can do anything with just the regular netcat. You can go NC 192.168.80.133 port 110. I don't know what's doing, but it's not important. You can connect to it with netcat. Sometimes they'll have, I don't know, some banner stuff you can look at, get some version info, but for us on this particular box, it doesn't really matter, so we can just move on from that. Our next important one is RPC bind, and you can enumerate this using RPC info, which used to be a standalone tool, but now it's just integrated as an Nmap script, so it runs it automatically when you run default scripts. The RPC info package doesn't exist anymore on Kali, as far as I know, because if you type in, oh, never mind, it does. Guess I'm dumb. But yeah, it does it automatically. Didn't work when I tried before, don't know why. But it tells us there's NFS running on the server, which is corroborated by the results of this port scan over here. That tells us there's an NFS ACL service running on the server as well. So NFS is like a file share, sort of similar to SMB share, if you guys have any experience with that. It lets you have a basically file system, storage files, directories, and all that. And you can access it from other machines remotely. So you can, if you've used Linux before, you can like mount a USB when you plug in. A lot of distros do it automatically, but if you're a beast like me and use no GUI whatsoever and don't automate anything because that's for plebs, you will like mount your USB after you plug it in. And you can do the same with NFS shares. You can mount NFS to like folders in your machine, which is pretty useful. And they are also exploitable, which is very good for us. So you can go on looking at like this exec login. Looks like it might be interesting. It's not that interesting. I looked it up. There's apparently like one RC exploit for something like that. It doesn't work. We also don't need these. This is just SSL versions of like the mail servers we saw previously for POP3. And here's our NFS server. So there's nothing else that interesting. I think the thing we'll focus on is exploiting the NFS share, since that's pretty cool and novel, I guess. But yeah, we can do that by using the NFS common utility, which isn't installed by default on Kali, at least not on this version I'm using. There might be newer versions out there. I haven't downloaded a new one in a while. If you apt install NFS-common, I've already got it installed. But what this gives you is the show mount utility. So if you go show mount H, there's some stuff. We're interested in show mount -E, and then you specify the name of the target, and it will tell you which NFS shares are available for you to mount on your own system. And there's one called Home Vulnix. And if you're smart and you're like a detective, big brain, you will also notice that this implies there's a user named Vulnix. So we can go back to 2.168.80.133.25 and then try verify Vulnix. We know that works. You might be able to brute force Vulnix. I didn't bother because there's another way, and Vulnix took too long. Their password might be in a password list. I don't know. Didn't bother. I don't think that's the intended way to do it, but it's good to know. You can like infer things like this and confirm them with verify and all that for extra user enumeration. We're going to focus on just the Unix username to user, because that's the way I did it, and I think that's the way everyone did it based off the write-ups I looked at after I did it. But yeah, we can see that there's an export for /home/Vulnix. So what we can do is just go to temp, go to /temp, because it's an absolute path, and then create a directory called fucking /temp/Vulnix. And then we can actually mount this NFS share to this folder and see what it does. There we go. And as you can see, we successfully mounted it here. And let's try to access it. Oh, permission denied. This isn't anything to do with like the permissions on our own file system, but if you do some research, you'll find there's a particular option for exporting these NFS shares called root squash. And as this blog explains, when you try to access an NFS share, you're basically trying to access it as the same user you are on your machine. So I'm root right now. When I try to access this, I'm trying to gain root access on the actual Vulnix machine, which you obviously don't want to happen. So you put in this thing, or this option called no root squash, which I've highlighted. And what this basically does is that whenever someone tries to connect to the NFS share as root, it pretty much maps their account to an account called NFS nobody, which is nobody, can't do anything, it's useless. So you get permission denied like this. Because the share is /home/Vulnix, we can make a reasonable assumption that the user Vulnix actually has access to this share, as if they didn't, that would be really stupid. So we're going to see how we can get access to the user Vulnix. We have that username's user, and the intended way is basically just to brute force the SSH for this user, because as far as I know, Vulnix has a pretty secure password that either takes forever to do using RockU or isn't even in RockU. But if you use the user, you can see that they have a very weak password. So the way we're going to do that is using Hydra, because Hydra's fine, it's easy. But something you'll notice is, I'll let it run for like 2 more seconds, should spit a message out. Here we go. Data max 4 servers, max 4 tasks per 1 server, because of how some configurations of SSH works. This is going to take forever, so I've just like pre-computed it off screen before I did it, or before I'm presenting now. And the password for user is let me in, which is one of like the first few hundred in RockU. That still takes like 5 minutes for this SSH, since there's only 4 tasks per 1 server. And so we'll just try to SSH in as user using the let me in password. But if you let this Hydra run for a while, it'll pop up saying we found a password for this user, it's let me in. So we'll do SSH user at 192.168.80.133. And we'll type let me in. And then we have this user access. Yay, we have user, but we don't actually, because this one's kind of useless. You can do ls-la, you can go up, you can try to access Vulnix, you don't have permission. So we're going to have to try and figure out some other stuff. Remember what I said about mapping users to the NSF share, and if we have the user Vulnix, we can map it to Vulnix on the remote machine. Well, we need to know the user ID as well, which we can figure out as user just by catting etc password. And if you cat etc password, you can see Vulnix has the user ID of 2008. So we could look around this machine. I encourage you to look around whenever you get some sort of foothold like this. But for the sake of time, we're just going to exit because there's nothing left for us here. So what we do is literally just create a user named Vulnix with the user ID 2008, which we specify with the -u flag on our system. And then we can access the machine. I thought this was pretty clever. If you Google like exploiting NFS share, you can find a bunch of really good articles which outline this sort of attack. But yeah, that's what we have to do. I already did it because obviously I've done this machine before. So we'll just switch user to Vulnix. And then we can ls and cd into Vulnix. And then you can see that we have access to Vulnix as user Vulnix, but we only have access through the NFS share. So we're going to try to get some proper access, like through an SSH thing or whatever. We can test our permissions, make dear SSH, And we know that we can create directories and touch files and things like that. So what we can do is create our own SSH keys, a private and public key share, and then access this machine via SSH. Because through SSH, there are two ways you can access it. One way is the way we just did, which is log in as a user, type in your password, then you have access to the machine. The other way is to validate using a private public key pair. You can store the public key in a folder in .ssh called authorized_keys. And then whenever someone tries to connect with the key, they can offer up their private key instead, verify it against your stored public key, and if it does all the crypto math stuff, you get access to the machine without a password. So we're just going to generate a pair on our own host machine, cd temp, and then we can use ssh keygen, ssh-keygen. Pretty easy, just type in the path, just like /temp id rsa, no passphrase. Then we can see that our files were created over here. Or just cat out idrasa.pub, and then we have this. So this entire string is just our SSH public key, and we can literally just echo into authorized_keys. I think that's right. Cat authorized keys. All right, looks good. So then from here, we can try SSH, use -i to specify that we're identifying ourselves with a private key instead of a password. -i id rsa, and then 192.168.80.133. If we don't specify username, it tries to log in as the user. We are on our machine, so we'll specify Vulnix at this thing. Then we have actual user as Vulnix. So now that we have an actual user, there's some information which we can try to use the privesk. The server spits out a bunch of this information, and initially looking at it, you see Ubuntu 12 that looks kind of old. There might be some kernel exploits. But privesk, none of them work. I don't know why I exited, that was dumb. None of them work. We can look up Ubuntu 12 and search exploit. Oops. Search exploit Ubuntu 12, there's a bunch of them which are like x64, and we can see here that it's a 32-bit system. So these ones are, you can just cross them out. This exploit, if you read the text and read the text for this one and look at the C code for this one, it relies on, the text one relies on GCC being on the actual machine, and we don't have GCC on the machine, so we can't use that one. This one, the C just doesn't work, so none of these privesks actually work. So it's not as easy as just compiling some sort of kernel exploit, putting it on the machine and running it. It doesn't work. Even though the last time the OS was updated was in 2012 for this machine. So we're going to look at the actual proper way to privesk. There's a really good guide which I not only use for OSCP and other stuff, but this one's really good for everything. GUIF.RE, and then if you don't use that directory, there's a whole bunch of notes on all sorts of different stuff. It's really good. I highly recommend bookmarking this and referring to it each time you do some privesk. I believe there's some stuff in Gotmilk's privesk guide that isn't in this, but this is more or less the most common stuff you'll be facing. So we can see here post-exploitation, add public key to authorized keys. That's just what we did with Vulnix. Escaping limited interpreters, we don't have to worry about that since we have an actual SSH connection. And manual testing, there are a bunch of scripts which you can download, then transfer onto the remote machine, which will automate all of these things. But I find that sometimes it's good to do them by hand, just because you pay more attention to the details. And if you run these scripts, you get an entire 50,000 line output of verbal spew, and it's easy to miss a bunch of these things. And when starting off, I recommend doing it manually, just because you'll be able to spend some more time to actually understand what you're doing and what you're looking out for. So simple sudo doesn't work. It did work for one machine for me once on like Hack the Box or OSCP Labs or one of those. But the one we're going to do is sudo-l. This shows you the things you can do as sudo or like as root. And this is a really interesting portion. A lot of machines will want a user to do like one particular action as a root, either like editing a particular file or some sort of config or things like that. But that's usually really dangerous, because if you let a user, say, run vim as the root on just one config file to do some random config stuff, you can easily break out of that. So if I like go into vim and then go type shell, bam, I have a shell. And if I was a low priv user and had access to vim on a remote machine, but the vim process was running as sudo because of this sudo-l configuration, if you type shell, the shell is running with the permissions that the actual vim process has, right? So if your vim's running as sudo or as root, your shell will be a root shell. So that happens fairly often. Also, just realized I haven't been checking chat. If there's anything I missed, forgive me, but I haven't seen anything so far. Feel free to ask questions. I want to take some time to explain this and make sure everyone understands what's going on. But yeah, there's a really good resource called GTFO bins, which tells you how to escape out of a whole bunch of these programs. If you have a sudo-l for nano, for vim, for any sort of editor, for a whole bunch of other stuff, apt-get, org, busybox, all sorts of crazy stuff, Docker even, find, finger, our good friend. But if any of these can run with sudo permissions without passwords, you can follow these guides to basically break out of them, get a root shell, or do something as root. Yeah, but unfortunately for us, sudo edit is actually safe as far as I know. There's no way to break out of it, but we are able to edit a particular config file called etc exports. And if you read the article I briefly skimmed over for the exploring NSF shares, you'll remember that etc exports is where the config for root squash is. So if we run sudo edit etc exports, we don't have to use a password, and we're editing this file as a root, and we wouldn't otherwise be able to deal with it. So we see here, we have home Vulnix, read write, root squash. So there are, from here, this sort of branches out into two different ways you can escalate privileges. I guess first I'll do it the way that I initially solved this before looking at different ways to escalate privileges. What I did was just add a share for /root and then gave it the permissions read write no root squash, because I had an idea in my head that I wanted to try out, and I figured this would be the easiest way. We will come back later and edit this configuration again to make the Vulnix directory no root squash, and I'll show you guys how to do that. But for now, we'll just do it this way because it's the way I figured it out, and I'm pretty sure it's the most common way other people did it. So we'll save that. And here's the, I think this is a good box for teaching people because there's a wide range of things you can do. But here's like one thing that really sucks. There's no way to reboot the box because it needs to be sudo, and you can't restart the service either because you need to be root for that. I really wish the creator would have put in some like clever way to get permissions to restart the service, because there is an NFS kernel service which you could potentially restart. Maybe they could do something clever with that, but they didn't. And from looking at like all the write-ups, you pretty much just have to hard restart the Vulnix box. So we will just exit unmount temp Vulnix, and then we'll go into VMware and just press the restart button on our Vulnix virtual machine. It's pretty disappointing, but it's just the only way you can do things. And it will start back up. And it's booted back up. So we will remount. If you don't know what this is, if you press Control R in Bash, you can like start typing a command and it will auto-complete it based off your history. And this just saves a lot of time remembering commands for me because I typed these in previously. I don't want to keep them on a sheet somewhere and look at them or like grep history or something dumb like that. Go back to mount T NFS. Then we have this one, but instead of mounting home Vulnix, we will mount root. And then we can see, oh yeah, I skipped something. If you go to show mount -E 192.168.80.133, you can see that there's not only home/Vulnix, there's now also /root since we changed the configuration file and we reset the machine. So now we do have root mounted to this folder. So we can just cd Vulnix, and we can see that we're actually in there, and there is trophy.txt. So if you cat trophy.txt, it doesn't work. I don't know why it doesn't work from NFS share, but it doesn't matter since this doesn't count anyway. Rooting a box means you have to get like actual shell access, and we're going to use this pretty much just as a foothold to get an actual SSH connection back to us. So we're going to do the exact same thing that we did with user, which is exploiting the whole SSH key thing. And here's one of the post-exploitation steps. We're literally just going to repeat with root in the root home directory, since when you try to connect to a machine as a user remotely, it will look in that the directory for that user in home, in home or whatever their home directory is. For root, it's /root. So if you have /root /.ssh, it will look in there for your keys. If you try to connect as root, if you try to connect as Vulnix, it will look in /home/Vulnix /.ssh and so on and so forth. So what we're going to do is just the same thing, make directory.ssh, cd.ssh, and then we will do the same thing. Echo id rsa.pub. Whoops, not echo, it's cat. Then we're just going to copy this, do the same thing, echo to authorized keys. Cat authorized keys, easy peasy, exit. And then we're going to ssh-i id rsa to 192.168.80.133. And bam, we are root, and we have an actual root connection. And we can actually cat trophy.txt this time. I don't know why it doesn't work in the NFS share, but yeah, now we have the root SSH thing. We can do whatever we want, blah, 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 my ID 0, we're root. Easy peasy. So that's the first way, and which is the way I did it initially. There's another way you can do it by modifying the exports config file a bit differently. So we can just exit here, and we will go back and connect there as Vulnix. So we will unmount the mounted NFS share from our machine, and then go back and remount it, not as root, but as home Vulnix. And then we will switch user to Vulnix again, and then cd Vulnix sudo edit etc exports. Whoops. I don't know why it's asking for it now. That's weird. We'll just restart the machine, easy peasy. I've had a couple issues like this, just because restart the machine, change the config, maybe some stuff changed. But yeah, easy as. We will just close Vulnix. It'll take like 2 minutes. Less time than it takes to do an Nmap scan. Please excuse me. Delete from disk. Cool, and then unpack. I'm just unpacking. Easy, I think that's done. I don't know how Zoom's dealing with me switching windows and stuff. Just please bear with me. Yeah, we just started a fresh instance of Vulnix. No biggie, you're not missing out on anything. Once that's back up, we can go back to Kali. Just make sure that's up. Cool, easy. And we will mount. There we go. And that's mounted. Switch user to Vulnix, CD, Vulnix, easy. So then we should do the SSH thing again, never mind. Our SSH key is still there, so we'll just open up a new thing, go to cd temp cat id rsa.pub, and then just repeat what we did before. Make directory.sh cd.sh. We'll just echo that into authorized keys again. Whoops, I didn't echo. I don't know why that's stuck. Cool, great, sick, fully sick. Alright, we're just gonna close that, try again. What was I doing? Cool. CD, then we'll echo into authorized keys, kind of authorized keys, make sure it's all good. Yep, and we will exit. And then try to SSH i.id RSA Vulnix at 192.168. Alright, easy. Now we're back into the machine and we have SSH access, so we'll just try it again. Sudo-L, and we can sudo edit etc exports. I don't know why it didn't work last time, why it started asking me for passwords. Probably because I changed some configuration. And this time around, we won't add a root directory to add SSH keys for root. We will try exploiting the fact that we can control files in it as root to create a binary with an SUID bit. So I'll go into that a bit later. But for this one, we don't have to add a new share. We're just going to modify the permissions on this existing one. So edit and save, and we'll leave this SSH open because we need it later. But yeah. Now what we're going to do is mount temp Vulnix, and we're going to have to do the dumb thing where we restart it again, but I'll take like 5 seconds. Awesome. So now if we show mount E, we do that, there's just one, and it's home Vulnix. So if we go back to mount that in temp Vulnix, we can go into it as a root this time, ls-la, and we can see the .ssh in there. So we know it's the driver that we modified and all that jazz. So this is pretty cool. We can go out, and for the sake of time, I will skip over one of my demos, but what I was going to do is demonstrate changing the SUID with bin bash and then just putting in there and having a bash executable binary that you execute from your SSH to get a root shell. But the point I was trying to make was that that didn't work because our Kali here is 64-bit and the Vulnix machine is 32-bit. So instead, what we can do, instead of putting the bash executable in there directly, we know that there is a bash executable that exists on the machine. Otherwise, you wouldn't be able to interface with it in a shell like that. So we can write like a really simple C wrapper effectively for our 32-bit bash on the machine. So just grab my notes up, see what I wrote. Cool. I have it. All right. You know, SUID.c, not vim. I know. So sad. What I wrote was int main void. What shortcuts I used. execl. What that does is just runs a file. So the file we're going to run, I'm going to specify as bin.sh or bin/sh. You can do bash, whatever, doesn't matter. 0, and put a colon at the end. And that's literally just a C program that runs bash. But it's an easy way to sort of have an adapter between your 64-bit system and the bash thing, because you can compile the C program in 32-bit pretty easily. So we will save that. That looks all right. We'll save that. And then if you are using a default Kali install and you haven't installed 32-bit libraries yet, GCC, you're gonna have to install it. It's like, just run apt search lib32 GCC, then you'll find, no, it's GCC-multilib, but something along those lines. You can Google it. And once you have it, you can just run this. Some warnings, we don't care because we're bad programmers and I don't care about warnings. And we can ls and then cp suid into Vulnix and cd Vulnix. And because we're root in the NSF share, we can add an suid bit to the executable. And what an suid bit basically is, if I can find a diagram, is, there we go. So this bit at the start, and when you have a root user setting an suid bit, it basically says that no matter who runs this program, the process will run with permissions of root. So this is a pretty, I guess, unique or contrived scenario where you have access to create these SUID enabled binaries, but usually in challenges you won't see this sort of thing. What you'll see instead is are binaries that already exist on the system with SUID bits enabled. And there's a really good command to find that in here, or series of commands. On next one. Here we go. If you have access as user, you can run these 3 commands from the GUI-free, however that's pronounced, from that privs guide. So these 3 commands, and sometimes you'll be able to find these permissions on executables on the remote machines you try to exploit. So it's just good to understand what SUID bits do. You'll rarely come across a situation where you can set your own SUID on a binary on a machine without also like just having an easy way to outright get root. This is a special situation because we have like file system access, and things like that. And even then, there's an easier way, arguably, just by putting your SSH keys on the machine. But this is more often what will happen. You can just find things on the machine that you can run and exploit. Maybe combine with things like GTFO bins to get yourself root access. But yeah, now we have this SUID file on the machine, and we'll chmod for 777. 777 is just like all access for everyone. We don't really care because we're bad people and not good people. And the 4 at the start is the setting the SUID bit. And if we do that for SUID, we can ls-la, and we can see that there's not RWX, but RWS on our binary. So it's pretty legit. If we run file on SUID, we can see that it's a setuid elf 32-bit executable. So that's perfect. We should be able to run it. Oh, I got disconnected. If we try to reconnect, we can see SUID there. And if we run SUID, we get the amazing, satisfying hashtag at the start of the line. So we type, who am I? It says root. We do ls cd cd root, and then cat trophy.txt id, who am I? And that's the second way you get root. So I hope you all found this informative. I won't keep you past 8 p.m. because that's my bedtime and I need to go to sleep as well. So I don't want to keep you guys up too late. And yeah, that's how you do Vulnix. I hope you learned something. If you have any questions, feel free to send me a message on Discord. I'm pretty active. You'll probably have a better chance just DMing me instead of pinging me from the channel because sometimes I have things muted. But yeah, I'm happy to help out if you have any questions. Hope you learned something. Hope you get some use out of this progress guide, especially. And that's all I have to say. Thank you.